Which material will be best at slowing down how quickly ice melts in a glass? An investigation into the properties of materials. Before we begin, we need to do a little bit of thinking and to work out some of the background science about what causes ice to melt and also what properties materials need in order to slow down the melting. Once you've worked this out, then you can come up with a hypothesis. In other words, what is, in your opinion, going to slow melting down and how is it going to achieve it? You now need to write this up in your book. Having done all your background work and figured out all the science behind what's going to be happening, now we need to start planning for the experiment itself. You need to have an idea of what materials you're going to choose. I'd suggest 3, maybe 4, maybe even 5. You need to know what you're going to measure and record. That's very important so that you can prove that what you thought was correct. What is it that must be kept the same to make sure it's a valid test? You might have used the word fair test in the past, but now we're going to use this word valid test. And how are you going to make your results reliable? Using the headings above, make sure that you now write this down and record it so that you know what you're about when you actually come to doing the experiment. The setup you should use is indicated in this diagram. You're going to need to have a material that goes all the way around your glass or your beaker, and your glass is inside that. Inside the glass needs to be your ice cube that's going to be melting, and you need a timer to work out how long it takes for the ice cube to melt in each case. Having got this clear in your head, you need to be drawing a diagram and you need to list the equipment. Once you've done that, you now need to come up with a method. It's a step-by-step process in order. I would use bullet points, please, telling us how to do the experiment. Now write this up. So we've done all our thinking about what the science is behind this. We've worked out what equipment we'll need and also what order we're going to do the experiment in. Now we need to write our results table and make sure that we're prepared to write those down. So here I've got my results table and we need to have a list of materials. You could only do 1 maybe, you might do 2 or 3 or 4, however many you've got time for. It's a good idea to do each one 3 times so that our results are reliable. Once you've done them all the 3 times, you can then get an average. So, for example, if I choose newspaper as my first material, the first time I record is 12 minutes, the second time 14 minutes, and the third time 13 minutes. This then gives me an average time of 13 minutes. Note that I don't write minutes here after each of the numbers. That's because we've already got them here in the title. Having done the experiment and got your results, we now come to the conclusion, a really important part. This is where you have to show what you found, explain what you found, and review how you did your experiment. Your conclusion can be broken down into your analysis and your evaluation. In your analysis, state what your results show, give an order if you can, and support this with numbers from your results. You also need to back this up graphically with some graphs and visually with charts. In your evaluation, you have to tell us whether or not your method was really good at giving us reliable and valid results that we can actually use to prove what you said at the beginning in your hypothesis. Do try to be critical and suggesting improvements. This actually shows some good science. Where then could this lead? Have you any further work or further questions you might like to ask and more experiments you might want to use to develop your understanding? If your evaluation, you say that your experiment wasn't very good, that's okay, as long as you suggest what improvements need to be made.